This video will help you better understand bond yields. It will go over a bond's yield to maturity, its current yield, expected capital gains or losses on bonds, as well as a bond's holding period yield. When you purchase a bond, the bond's price, coupon, face value, and time to maturity determines its yield to maturity. How long you hold a bond and changes in interest rates will determine your holding period yield. Let's look at a bond's yield to maturity first. A bond's yield to maturity is determined by its selling price. Let's consider a bond currently selling for $940 with 8 years left to maturity that has a 6% annual coupon or a $60 annual coupon and a $1,000 face value. Using a financial calculator, tables, or an equation, we can solve for the rate or the yield to maturity, which in this case is 7%. Now, if the bond's price was lower, say $850, its yield to maturity would increase because we're paying less cash in terms of cash outflows for the same cash inflows. At an $850 price, the yield to maturity would be 8.6%. On the other hand, if the bond price rises to say $980, we would have a lower yield to maturity because we're paying a higher price now for the same cash inflows or returns. So remember, there's an inverse relationship between bond prices and interest rates or the yield to maturity. When bond prices go up, our returns go down. When bond prices go down, our returns go up. From a return perspective, we are only guaranteed to earn our implied or expected yield to maturity, that is, the yield to maturity at the time we bought the bond, if one of two things happen. First, if we hold the bond to maturity, and second, if interest rates remain the same. This is because if we hold the bond to maturity, we're insured of receiving the bond's face value, or in the case of our bond, the full $1,000 when we redeem the bond. If interest rates remain the same, a bond's future selling price will change, but it will change exactly as we had initially expected. This means we won't have any unexpected capital gains or losses. Let's look a bit closer at a bond's yield to maturity. It has two components. Its current yield, which is simply the coupon divided by its current price, plus any expected capital gain or loss. And again, that's simply any expected change in the bond's price. So our total return, or the yield to maturity, can be thought of as a simple equation. The current yield plus or minus any expected capital gain or loss. In terms of expected capital gains or losses, when we purchase a bond at a discount, that is less than its par or face value, we're expecting it to increase in value and we're expecting a capital gain over the bond's life. On the other hand, if we purchase bonds at a premium, we're expecting the bond to decrease in value or we're expecting a capital loss over the bond's expected remaining life. Let's go ahead now and examine the yield to maturity when we hold a bond until maturity. We're going to look at a bond purchased at par, a bond purchased at a discount, as well as a bond purchased at a premium. Keep in mind, our total return from buying a bond has two parts, the current yield and any expected capital gain or loss. First, let's examine the yield to maturity when we purchase a bond at par value. Let's consider the case of a 10-year bond with a $100 coupon where it's selling currently for a price of $1,000, so it's selling at par, which means our yield to maturity will be 10%. Notice, since the bond's selling at par and the interest rate remains constant, we will not expect any change in the bond's value over the bond's life. So our total return, made up of two components, is the current yield, which is the $100 coupon divided by the $1,000 price, plus nothing in the terms or form of a capital gain or loss. Now let's consider a bond that we purchase at a discount. In this case, we're going to assume we have an 11% required rate of return or yield to maturity. Since the yield to maturity required rate of return is higher than the coupon rate, the bond will sell at a discount. But notice, over the next 10 years, we're anticipating that bond to increase in value, and at the end of 10 years, we will expect to get the full $1,000 back. This is simply our amortization table. Let's look at our 11% total expected return. In the first year, we're expecting a current yield of 10.63%. And again, that's simply the $100 coupon divided by the current selling price. We're expecting the bond to increase in value by 0.37%. It's going to go from $941 to $944. In the second year, again, we'll expect to earn an 11% return. Since the bond is worth more now, its current yield is slightly lower, but we're anticipating a slightly larger capital gain. In every year, the current yield plus our expected capital gain gives us our 11% total return, which was our bond's yield to maturity. And we'll be assured of earning this return, provided we hold the bond to maturity or interest rates don't change. Now let's consider a bond purchased at a premium. If we require an 8% return, we will be willing to pay $1,134 for this bond, but of course we'll only get $1,000 back at maturity, so over time we're expecting the bond to decrease in value, resulting in an expected capital loss. But notice, every year our current yield plus that expected capital loss equals our total return or our expected yield to maturity. Things get more interesting if we sell a bond prior to maturity. Our holding period yield, what we actually earn, might not equal the expected yield to maturity. It will depend on if and how interest rates change. If interest rates remain constant, our bond price will change exactly as we expected it from our bond amortization table, and our holding period yield will equal our yield to maturity. Let's go back to our bond sold originally at par value. Let's say we hold the bond for 3 years. We're expecting to be able to sell it in 3 years for $1,000. And we could simply calculate the selling price in 3 years by putting in a 10% interest rate, $100 the coupon, the value at maturity, the 7-year remaining life, and solve for the present value. So the bond's future selling price is exactly what we had anticipated, so we don't have a gain or a loss. And we could solve for our holding period yield by simply entering in the price we paid for the bond, $1,000, what we sold it for, $1,000, the annual coupon received, and the fact that we held it for 3 years. And we could solve for the interest rate, and that would be our 10% holding period yield. And again, the holding period yield equaled our expected yield to maturity because interest rates remain constant and the bond price changed or didn't change in this case as we had expected. Now let's consider what happens if interest rates increase. Recall, if interest rates increase, bond prices will decrease. Therefore, we'll have an expected loss, and our holding period return or yield will be less than our expected yield to maturity. Let's look at an example. Going back to the bond that we purchased at par and expected to sell in 3 years, and we expected to be able to sell it for $1,000. But now interest rates have increased. We're assuming they increase from 10% to 12%. If interest rates increase, people won't be willing to pay par value or $1,000 for the bond. In fact, we can solve for that expected selling price in 3 years. Recall, at this point in time, the bond has 7 more years to maturity, and at maturity we'll get $1,000. So we can put $1,000 in for the future value, $100 for the payment. We'll receive that for 7 periods. If we require a 12% return, the buyer of this bond will only pay $908. Now, using that $908, we're ready to solve for our holding period yield. Again, we paid $1,000 for the bond. We sold it 3 years later for $908, and we received $100 a year for 3 years. enter those into your financial calculator, and we can solve for our holding period yield, which is only 7.17%. It's less than the 10% initial yield to maturity we expected because interest rates went up and we had an unexpected capital loss. As a final case, let's consider what happens when interest rates decrease. Of course, when interest rates decrease, we expect bond prices to increase, which will result in a capital gain, and our holding period yield will be higher than our expected initial yield to maturity. Let's take a look at an example. We've got our same initial bond that was purchased when interest rates were 10%, selling at par. If interest rates drop to 8%, people won't be willing to pay $1,000 for our bond. Again, our bond now has 7 years left, $100 per year. We're going to get $1,000 when it matures. Since interest rates have gone down, this looks like a great bond, and the purchasers will be willing to pay $1,104 for our bond. Let's look and see how that impacts our holding period yield. Again, we purchased the bond initially for $1,000. We now can sell it, though, for $1,104, much higher than the initial expected selling price. We held the bond for 3 years. We received $100 per year, and we can solve for that holding period yield, which is 13.05%. Our holding period yield was greater than our yield to maturity because the bond increased in price unexpectedly and we had a capital gain. Again, work through the Excel worksheet, try some different changes in bond prices and changes in interest rates, and see how our total return is made up of two components, the current yield and our expected capital gain or loss. And if interest rates go up, we will have an unexpected capital loss and a lower than anticipated holding period return. And of course, if interest rates go down, bond prices will go up, resulting in a gain and a higher than expected holding period return.